Question 10. The IQs of 400 randomly selected students show a mean of 107, standard deviation 15, 95% confidence interval for the population. Okay, 1.96 multiplied by standard deviation of 15 divided by the square root of the sample size, which is 400, which is 20, so that's just 3/4. 15 over 20 by 1.96 is 1.47. 3/4 of 1.96. So my mean is 107. So 107 plus this 1.47 and 107 minus this 1.47 is going to give me 108.47 and 1065.53. So my 95% confidence interval 108.47 or mu less than or equal to 108.47 and 105.53 at the lower end, greater than or equal to. So what are we asked for in part 2? We're asked for constructing the confidence intervals for 90 and 99 using these formulas. Okay, let's do 90 first. E90 is 1.645 multiplied by 15 divided by square root 400, and that's going to give me, it's going to be 1.233. I'll leave it at 1.23. And then E99, what's going to happen here? We have 2.575 multiplied by 15, just multiplied by 0.75 at this point, but let's just write out what they have. And this is 1.93, 125, 1.93. So what's happening at 90? We have 1.23 as the plus or minus. At 95, we got 1.47. And at 99, it's increasing to 1.93. To comment on these results, I would say that the confidence interval gets wider the further we go along. The more confidence we have, we can be saying 99% confidence of this wider confidence interval, and obviously the narrower the interval gets, the less confident we get. Is that the last part of that? I think so. Question 11. Turn off your phone when you're working, or mute it, or just let the ringtone go into your videos. Data collected by child development researchers produced this confidence interval. So what we need to do is we need to decide how much did it jump that way and how much did it jump that way. And by doing that, we just get the midpoint. So if I add them together, 31.844, 29.202, 6, 4, 0, 10, 11, 61.046. And if I divide that by 2, I'm going to get 30.523. So that's going to be the midpoint. So how much have I added on? To 30.523. Well, if I take away 29.202, it will tell me what I've added on and taken away. So 1, 2, 3, 1.321. The margin of error in this case is 1 point plus or minus 1.321. If the researcher had calculated a 90% confidence interval, would the margin of error be larger or smaller? Well, from the previous question, we saw that as we went from 99 back to 90, the margin of error got smaller. So that's what we're saying here. If the 90% confidence interval has a smaller margin of error than the 95 or the 99 or whatever one we're looking at. So 90% confidence interval, smaller margin of error. The radius starts off big at 99 and reduces down. This margin of error gets smaller within these distribution curves. So that's the end of this video.